All right, so we're going to pick up where we left off in the notes yesterday. So we did all these notes about mid-segments on this yellow packet. So if you flip it over, you'll see there are just two more slides that have to do with a perpendicular bisector. So that's the next object that we're going to learn about. If you remember, I said in class yesterday in chapter 5, there's 5 different objects, and we already talked about a mid-segment, and a perpendicular bisector is the next one. So the perpendicular bisector theorem says that in a plane, if a point is on the perpendicular bisector of a segment, then it is blank from the endpoints of the segment. So first you have to know what a perpendicular bisector is. So it kind of spells it out for you, because perpendicular obviously means 90 degrees, and then bisector means cut in half. So it's an object that cuts a segment in half and intersects it at 90 degrees. So you can see in this picture, CP is the perpendicular bisector. 90 degrees cuts AB in half. So then the answer to this blank is, in a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So again, it's talking about a point that's on the perpendicular bisector. So it would be talking about this point C right here, because we said CP is the bisector, and it says a point on the bisector. So what it's telling us is that C is the same distance to A as it is to B. And again, down here it says if line CP is the perpendicular bisector of segment AB, then CA equals CB. Now this one, the converse, is the same thing, just in reverse, so it works both ways. In a plane, if a point is equidistant from the endpoints of a segment, so if you take a look at like D here, for example, it's equidistant to the endpoints of the segment, then it is on the perpendicular bisector of the segment. And you can see we couldn't tell that already because CP stops short before it gets to D. So it's not enough to say, well, it looks like D is going to lie on that line. You have to have a reason that you can back that up and guarantee that it's true. And the reason would be because it's equidistant to those endpoints. So if DA equals DB, again, D lies on the perpendicular bisector of segment AB. So now there's just 3 examples, and these are usually pretty self-explanatory. They're pretty easy to see. There's a few little things that you might get tricked on. So number 1 says, find the value of x if line AC is the perpendicular bisector of segment BD. So it's telling me AC is the perpendicular bisector, so that means it's perpendicular to BD, cuts it in half, and they want us to solve for x. Well, hopefully you can see then that based on that perpendicular bisector theorem, that A is on the perpendicular bisector, so it's equidistant to the endpoints of those segments. So 7x minus 6 has to equal 4x. And when you go ahead and solve that, you're going to get an answer of x equals 2. Now, number 2 kind of goes back to what we talked about in the converse, theorem 5.3. It says line KN is the perpendicular bisector of JL. So KN is a perpendicular bisector. Does point M lie on the perpendicular bisector? And again, this is where people always want to say, yeah, it does, because it looks like it does. KN's going to go right through it, but you can't assume that. So our reason is yes, because JM equals ML. And again, that theorem says if it's equidistant to the endpoints of the segment that's being bisected, which in this case is J and L, then it has to lie on that bisector. All right, last one. It says line FH is the perpendicular bisector of DG. So as soon as you see perpendicular bisector, you want to think 90 degrees, and it cuts it in half. Find the value of y. So this is telling me that DH is 2y plus 3, and GH is 7y minus 42. And because of this perpendicular bisector, these are the 2 pieces that were cut in half. So I'm going to take 2y plus 3 and set that equal to 7y minus 42. The good thing about this is you don't really have a lot of options in terms of writing equations. Oh gosh, the lights just went out. Hold on. Motion sensors. You don't have a lot of choices in terms of writing equations like 180 or any other special measurements. So a lot of the times you're going to be setting things equal unless it's a special case. So when I solve this, I get 45 equals 5y, and y equals 9. And that's it for perpendicular bisectors. The next thing we're going to talk about is angle bisectors, which you'll find is extremely, extremely similar to perpendicular bisectors.